Welcome everyone. I must warn you at the beginning, I won't show any Java code, so I won't feel offended if you leave now. Thank you. We'll talk about visual search today. How many of you are familiar with the idea of visual search? Some hands, nice. How many of you ever uploaded the image to search for other images? Congrats, you used visual search. So right now, when we are on the same page, my name is Ola. I'm a software engineer. I come from JVM world, but I did coding in Python as well, in COBOL in some old good days. I work at Tipser. This is e-commerce company based in Stockholm, Sweden. We work on shoppable content and inspirational shopping. What it means is when you read the article about trends, for example, and you see the cool product inside the article, you click buy button, and you're not moved to other page. It's not affiliate link, but instead you buy here on the widget on the same page. It's us, so we work like that. Imagine you go to visit your friend, and there is this cool painting on the wall. So you snap a picture of this painting because you want something like that as well. You upload that to Pinterest, and this is the result. It's pretty accurate. You see something similar, some similar paintings. You can buy it even, or you can paint it yourself. I do some paintings on my own. I'm not like super skilled, but still I can do something like that. But why? Let's start with why we even need visual search and why it blooms right now. First of all, as humans, we think with images. Our brains process images faster than text. Actually, 60K faster. I'm not sure how they measure that, but this is what American scientists say. And image is international. If you ever worked with international search, there are stop words. Those are the words that are meaningless. So for example, if your query is to be or not to be, Elastic will say, sorry dude, no results. Because all of the words come as stop words, so they are completely ignored. And you need to define stop words for every language. You need to translate names and descriptions of products or items. And you need to handle bad images. By bad images, I mean the images of incorrect variants. For example, our famous Vita score. Vita score, if you're not familiar with Swedish, is white shoes. So if you type white shoes, what Elastic does, it takes white, it takes shoes, and it tries to combine it somehow. So it looks for white items and for shoes, and this is what we get. Not very accurate. Because besides the white shoes, you get black shoes, and maybe if you click that black shoes, you will end up having white shoes as an option, but the image doesn't really match, right? And you get some furniture, and it's like really crappy result. Other thing is that we sometimes don't even know what to look for. So if you didn't take that picture of that old painting, you come back home and you type red painting into Pinterest. And this is the result. Not so accurate anymore. You get some colors, you get some furniture, you get some old paintings, but they are not really similar. And is it even red? This is the perfect audience to talk about colors, right? We all respect and know colors. So I would say it's red, but some merchants who deliver information about products would say it's a burgundy, or even memory of a sunset. And probably no one will ever search for memory of a sunset as a color for red dress or red painting, right? We have the right hardware, but to be honest, computers were ready in 80s, and some algorithms were ready long time ago, but we weren't ready as customers, as users. So we didn't need the image recognition and the visual search. Computers are way cheaper than they used to be, and we have cloud. So no more excuses. There's a bunch of cloud services that you can use. You get the free start, and if you turn off and on the machines instead of allowing them running all the time, you get a year or even more for free. Then you pay what you use, so it's really easy to start playing with machine learning, having really powerful machines. Yeah, but why now? Visual search was around for years, and it bloomed just like the last 5 years. And if you think of companies like Zalando, like Amazon, like Wayfair, they sell furniture online, it's obvious that they are interested in visual search because of money. But if you think of Snapchat, for example, or Google Lens, do you think of them as e-commerce companies? I'm not. I don't go there for shopping, but actually they sell stuff, they do the e-commerce, and they try to solve problems of society right now, which is impatience, and they try to give us inspiration to make us buy at the moment. And if it's slow, it won't work. So they are not only trying to give you relevant content, but also make it fast. And here are some numbers. This is something that is the argument why you should care as developers. So first of all, the 90% of information received by the brain is visual. So we will use images more and more often. And viewers are 85% more likely to purchase a product after watching a product video. 85%. So most of the customers who are convinced visually will buy. 62% of millennials want visual search more than any other new technology. Really powerful. And the study was done 2 years ago, so probably now it's even more. And 50% of responders said that they prefer visual information over the text. It's not that they have both at the same page. They need only images. So for fashion or furniture, etc. It doesn't apply for electronics though, and spirits. If you think about electronics and spirits, I see some strong IT influence here. Don't you think so? So it's really important to be part of this change. Let's talk about tools and your workshop. So basically, to implement visual search, you can go 2 ways. Image to text or image to image. For the end user, it's always image to image, but you can do some workarounds in the middle. And actually, the third-party tools do it as well. So if you think about image to text, you basically take the picture and translate it to tags, to some labels. And if you want to create your own model, you just prepare the list of tags. Those are some concepts. Or you use the ready ones. If you use the ready ones, you can skip point 2 and 3, which are prepare the training data. You put all the images into right folders, and then you train the model based on that. You validate it, you test it. Then if it's done, the user uploads the image, or you upload the image, and you extract the tags from the image for every image you have in your dataset. And this example here is from Google, I think. And it's pretty accurate even for the fashion world. You will see some less accurate tagging in a minute. I need to say something about fashionist. How many of you ever heard about Kunysz? Great. For those who haven't, it's a data set of handwritten digits. And the problem with Kunysz is that you can test your model over that data set. If it works, it won't probably work in the real life. If it doesn't work, it won't work at all. So Zalando a couple of years ago created this data set with fashion items. They have also 10 categories, but those are real pictures from their store. So they have 60,000 images, 10,000 of training set. Each image is 28 to 28 pixels grayscale image, and it belongs to one of 10 categories. So this is my simple model that I tested with Python and some libraries. This is on Jupyter Notebook, but here you have the link to Colab, and you can test it on your own. So this is very simple model with some layers, and as you can see, I train it against the training data and validate it against the validation data. And I have 10 loops. As you can see, I got pretty good accuracy of almost 90%. Not bad for this simple model. And the good thing is that here you have, here you see that the number of, the accuracy is growing. If it goes down, it means that your model is overtrained, and it's really bad, so you need to go back and improve your model somehow. So I tested that against some real pictures from the internet, and on the left, you see the pictures from the training data. So they are simple, flat clothes. So if I pick the images that are similar, for example, a pair of jeans or a sandal, which is very similar to the training data, the model got it exactly right with 100% of accuracy. So the first one is a trouser, and the second one is sandal. Pretty good, right? 5 minutes of coding, and here we are. Unfortunately, for more complex pictures, like the first one, it's like not very clear, but it's a dress. And the model said it's a sandal. And the second one is a sandal, but the model said, it's mostly, like, I'm mostly sure that it's a bag. It might be a sandal as well. So it's not so bad, but still it would need some tuning. You may also use the third-party tools. They have diverse results. Of course, pricing differs. But the API or SDKs that they provide are pretty the same. So for developers, it doesn't really matter. It matters what kind of data you get from them. So here is the example. The one on the right you have already seen. This comes from Google and is the most accurate. But for example, these are not really useful for me in e-commerce, because I already know it's a woman and it's a model. and even I know it's a dress. So I would like to know what color is that, I don't know, some patterns maybe, the shape, etc. So it all depends what you're looking for. So if you take the model that is trained on cats and dogs, and you want that to label your fashion items, it won't work. And the other way around as well. If you have the labels, you may use it in the text search. So what you do, you take all the images, you tag them, you save that in Elastic, for example, and then when the user uploads the image, you take the tags from that image and use it in Elastic in the text search. So what you get is a bunch of images, but it's not based on the pixels, it's based on the tags from the images. So it's a workaround. But it's cheaper solution than buying image-to-image third-party tool. So you may think of that. And it's really useful to add some context. So for example, if you know the category, or at least the department, then you can add it to the query, because you never search the entire database, because it doesn't make any sense. It's slow and it's a lot of computation. Now, when you know how to do image to text search, let's talk about image to image. So you pick the good model. If you have some spare years to use, you can build your own. Some companies that use image to image search claim they work on the model for 15 years. So if you have time, be my guest. Then you extract the features from images in your data set, and this is the most heavy task. So it needs a lot of time, needs a lot of computation. Then when you have everything trained, you upload the image, you extract the feature. The feature is basically a semantic hash. So it's saved as a vector. And you search for the nearest vectors, the most similar ones. Sounds easy, and it's done by external libraries mostly. So for a developer using libraries, it's fairly easy to start with. But visual search is very easy to start with, but to make it accurate is really, really hard. So here is the sample project that is done by Yusuke Matsui, who is a professor at University of Tokyo. And what he did was the simple image search engine, and I tested that. So what he does is, like I said, feature extractions. He saves all the features in this folder. PKL is some Python representation for the vector. The images are stored here, of course, in the image folder. And then when everything is trained, you start the server and you upload your image, which is translated to the vector as well. And he uses a convolutional neural network called VGG16, which is trained on the ImageNet. And ImageNet is a huge data set of almost 15 million images divided into 1,000 categories and even more subcategories. It's collected by the people. I love internet for such things. It also organizes challenges. So every year there is a challenge for model, and this VGG16 won one of those challenges. And it sets trends for the whole machine learning world. And VGG16 is the winner of the challenge of 2014, and it has up to 90% of accuracy. You may say, hey, but you also got 90% of accuracy with much simpler model, right? But this is trained against the whole ImageNet and not some, bunch of images only. So as you can see, there's lots of layers. And here is the whole code from this project, from this simple project. Probably you can write it in Java. It will take like 4 times more lines, but it will work. So you don't need to like remember all the things, but the most important things, the most important lines are these. So here you say you pick VGG16 with the wages, which is pretty much the metrics from ImageNet. Then you have this pre-processing, which is subtracting average values from each pixel, and then you create this vector that I talk about. As simple as that. So example was done on cats, of course, because the internet loves cats. But I did my testing on Pokemons from Kaggle. Kaggle is a place where you go when you want a data set to test. So I did a query with Pikachu, for example. I was surprised a little bit because some of them, I didn't expect them to be like similar to Pikachu, but they are in some way. And based on that example, I will tell you about challenges in a moment in Visual Search. You may also use the third-party tools. Most of the ones that I mentioned previously, they of course have diverse results, diverse pricing, and if you want to test it as developer, I recommend to start with Clarify or Google Cloud, because the rest, there is lots of hassle. You need the demo from the company, sometimes you need to sign a contract, etc. With these two, you can start immediately coding, which is fun. So let's talk about challenges. What's hard in Visual Search and where we can improve, what to test. Images quality. And I'm not talking only about the images in your own dataset, but also the images that will be uploaded by your users. So the model posture is one of them. Especially for fashion, sometimes the results are not related to the clothes that the model is wearing, for example, the pair of jeans, but rather the posture. So the model stands like that, so you look for images with similar model's posture. And here, Pikachu is somewhere in the results, but it should be the first one, and it's not. The background noise. Here, the background noise happened to be Pokemon Go logo, and if you look at this bird, it totally looks like this logo. So if you do the visual search, you need to take the object that you are interested in instead of looking in the whole image, because the result will be biased. Training data versus real life. Probably someone who uploaded this hangover Pikachu was thinking about Pikachu, but the results are not related to Pikachu at all. Because people will snap pictures on the street, on the concert, they will be poor quality images, etc. So you need to be prepared for that. So they won't have pictures of like flat-lying fashion items or exact Pikachu. They will have real-life images, and you need to use such images in your training as well. Dataset relevancy. I mentioned already that if you do the training on cats and dogs, you can't expect that model to work well on the fashion items. And here, it's surprisingly accurate though. This first Pokemon looks, or the second one, looks like hot dog a little bit. And I'm not sure if you've heard about this application. Is it a hot dog? It was created somewhere in Silicon Valley, and it answers one question. If the object snapped is a hot dog. So if you have the zigzag of ketchup on your shoe, it will tell you that it's a hot dog. It's hilarious. I recommend checking that out. Colors. Since we all love talking about colors, I have a couple of challenges connected to that. The dominant color versus object color. Sometimes you have lots of stuff going on in the background, some other colors. So for example, here, the dominant color is blue and maybe pink or, I don't know, violet. So you see that in the results. The result is biased by the dominant color of a picture and not the color of the object that you're looking for. And if you have multiple items, it also affects the results. So for example, here, you have actually two objects. You have Pikachu and Ash. And actually, the model doesn't know what to look for. So most of the results are related to Ash and not to Pikachu. And how you can handle that in real life, you may ask a user to precisely tell which object is the object that you look for. For example, if you have fashion items, you have like a pair of jeans, you have t-shirt, and I don't know, you have bag, glasses, etc. You may ask a user, hey, is it the jeans that you're looking for, or a t-shirt or something? And color bias. As you can see here with this blue Pikachu, most of the Pokemons are blue, or blue related at least. I'm not sure about this donkey though. This is surprising. The surprise factor is actually a really good idea, because if you suggest similar products, for example, based on the image, you may get stuck looping over the same data. So sometimes it's good to like add some surprise factor, add some if at the end of a query. Training data size. We all know that the big data is hard, right? But I'm not talking about that. I'm talking about you preparing the great data set with good images and diverse images in each category and subcategory, which is grouped by department, and you need lots of data. You need a massive data set for visual search to work fine. And response time is also a challenge, especially if you are a company like eBay, where your images change every day because people sell, people buy, so they add new images, but they also sell stuff, so images disappear. So for example, eBay trains their models every couple of days because their data set is changing constantly. And then to make it fast, you need to make it fast, because otherwise your customers will go away. I'm giving a presentation about performance, and there is this slide about impatience, and it says that if your loading time is 1 to 5 seconds, the probability of users leaving your page is 90%. So people are really impatient nowadays, and you need to give them fast responses. So if we recap what we've learned today, visual search blooms now and will get more popular. You may jump into that speedboat as a company and as a developer, because more and more hands to work with that will be necessary. You can ignore it. Like, for example, 2 years ago, blockchain was the #1 topic at conferences. Now it's machine learning. But I think machine learning won't go down as blockchain did, because we will need more and more hands to work with that. You can do visual search on your own. You can use tools or make a combo. So use tools for image recognition only, for image tagging, and then use it in your Elastic under the surface. So your users won't know that, but it will still work efficiently and fast. and you need good quality images, and you need massive amount of images to make it work fine. And I know you were curious about my personal opinion, which Pokemons are similar to Pikachu, so here it is. I picked the most relevant ones. We may discuss if you agree with me after the presentation. So here is more. I will put that presentation on my Twitter if you're interested. There's lots of knowledge in the internet, not only about visual search and this business side of it, but also about the technical details, the machine learning details, and how it works, and where are the projects, and what are the data sets that you may use. Lots of knowledge if you're interested. Keep calm and learn linear algebra, because at the end of the day, it's all about multiplying matrices. You don't need to code it yourself, but you should understand what's going on there, because then it will be easier to debug it or tweak it, improve it, etc. So it's always better to understand the stuff, how it's going on under the surface. You're awesome for staying with me this long and talking about Pokemons. We have some time for questions, so let me check the questions now. If you have any, of course. Which Pokemon? Pikachu, of course. Which one is better, TensorFlow or PyTorch? Unfortunately, I cannot answer this question because I've never tested PyTorch. I know TensorFlow is really, really powerful, and I know the majority of people use that one. No more questions? All right, then thank you very much.